So what is their answer to this? Do they have a solution? Well, no. They actually have 10 to the 500 solutions. It's a 1 with 500 zeros after it. What do I mean by that? Well, this comes from something called string theory. String theory is the idea that the subatomic particles that we're familiar with aren't actually particles. They're actually little strings. So they're not three-dimensional particles. They're actually 10-dimensional strings. Well, then why do they look like three-dimensional particles? Because the other 7 dimensions are rolled up so small we can't see them. Now, this is claimed to be an explanation for lots of things in physics. Without delving into details, I'll just point out that string theory, unlike its name, is not a single theory, and it's not a single equation. It's actually a set of equations without a unique solution. There are actually 10 to the 500 possible solutions for string theory. So which one is correct? Well, most people today are saying all of them are. Each equation represents an actual universe somewhere with different laws of physics, represented by that particular set of constants and solutions to the equations. So let me repeat that. 10 to the 500 universes. Now, right out of the gate, we might be scratching our heads. The universe is everything there is, so how can there be more than one of that? Well, because they redefined the word universe to mean that which we can observe. Not necessarily that which we can observe today, but that which we could ever potentially observe, even with the best possible equipment. So we do not live in a unique universe. We live in one of 10 to the 500 universes, which can have infinite combinations of different, I shouldn't say infinite, myriad combinations of laws of physics. Now, that sounds like a pretty goofy idea. What's driving all of this? Well, because without string theory, we would be left with no other rational explanation for the illusion of a designed universe. See, the idea is, they admit our universe is extremely unlikely. 1 out of 10 to the 120th power, right? I mean, that's impossible, basically. But if you have 10 to the 500 universes to pick from, there's going to be one very unlikely in there somewhere, and we just happen to be in that one. Even this, though, isn't sufficient for some people. So many cosmologists are now teaching there's actually an infinite number of universes. And this comes actually from our good friend inflation. Inflation, when it was first proposed, was thought to be a fairly simple process. As subsequent work has been done, they find out that no, it's not simple. Inflation did not stop all at once. It would break down, to make a long story short, and you would have eternal inflation going once it started. It can't stop. As this quote says, once inflation starts, it's nearly impossible to stop. An infinite multiverse of universes is formed. Multiverse equals multiple universes. Even in the tiny pre-inflation cosmos, quantum fluctuations ensured that the inflaton field, remember that particle that nobody actually knows what it is, had different energies in different places, a bit like a mountain having many balls balanced precariously at different heights. As each ball starts rolling, it kicks off the inflation of a different region of space, which races away from the others at speeds above that of light. Blah, blah, blah. Key point. An infinite multiverse of universes is predicted by inflation. Now, this has some pretty weird ramifications, as this paper began with. Is there another copy of you reading this article, deciding to put it aside without finishing the sentence while you are reading on? A person living on a planet called Earth, with misty mountains, fertile fields, and sprawling cities, in a solar system with 8 other planets. This paper was published right before Pluto got demoted. The life of this person has been identical to yours in every respect until now. That is, when your decision to read on signals that your two lives are diverging. You probably find this idea strange and implausible, yet it looks like we'll just have to live with it. Since the simplest and most popular cosmological model today predicts that this person actually exists in a galaxy about 10 to the 29th meters from here. The software doesn't allow me to do 2 superscripts, but this is 10 to the power of 10 to the 29th. So this person is very far away from you, but with an infinite number of universes to choose from, there's going to be one identical to this one, with just 1 or 2 small respects. There's a universe out there just like this one, where someone with your name and looking like you in your history had something different for breakfast this morning. There's a universe out there where the South won the Civil War. There's a universe out there where fill in the blank. Anything you can think of. Because there's an infinite number to choose from, so everything is going to be there somewhere. This does not even assume speculative modern physics. Merely that space is infinite and rather uniformly filled with matter, as indicated by recent astronomical observations. Your alter ego is simply a prediction of the so-called concordance model of cosmology, which agrees with all current observational evidence, if you make certain assumptions, and is used as the basis for most calculations and simulations presented at cosmology conferences. If space is infinite and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. In particular, there are infinitely many other inhabited planets, including not just one, but infinitely many, with people with the same appearance, name, and memories as you. Indeed, there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. This is mainstream. Let's focus on this one sentence. Even the most unlikely events must take place somewhere. We'll come back to that. And again, remember that some versions of this say that different laws of physics can apply in different universes. Now, I just told you this is mainstream, and you still might find this kind of hard to believe because this whole idea sounds pretty weird. But no, this is mainstream. I mean, lots of books are coming out on this. Article New Science has said, our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing like can you supersize or not, says this theoretical physicist. Our own cosmological history, he says, tells us that it's there and we need to deal with it. So if you find this idea too weird, well, you better just deal with it. Is this good science? By definition, all these other universes are unobservable by us. Again, even if we have better telescopes, best telescopes possible, can't do it because, for example, inflation, there's inflation going on faster than the speed of light, which prevents light ever traveling between the universes. Thus, we could never see, observe, measure these other universes whatsoever. So to invoke things that are outside of our observation doesn't sound like good science to me. Especially when the primary motive is, in this case, inflation, which is to rescue your theory from fatal observational problems. It interests me that something like inflation is presented as evidence for the inflationary Big Bang model, when inflation is where the actual data behind the inflation in the first place is data against the Big Bang model, if that makes sense.